All right, so if you're a .NET developer, you're working with databases. It's just part of the job. But how does that connection actually work, especially with today's modern distributed apps? Well, today we're diving deep into the framework that makes it all happen, ADO.NET. We're going to skip the 101 stuff and get right to the core architecture that really changed the game for how .NET apps handle data. To really get what ADO.NET is all about, we have to start with the fundamental problem it was designed to solve. In the age of the internet, you just can't assume you'll have a constant, stable connection to a database. So the big question became, how do you build solid applications that can grab data, mess with it, and update it, all in this kind of disconnected reality? The answer to that question, well, it required a bit of an evolution. See, before ADO.NET, we had its predecessor, which we now call Classic ADO. But as applications started moving to the web, that old way of thinking about data access just wasn't going to cut it. A massive shift was needed. And the philosophical change here is it's huge. Classic ADO was built for a world of persistent connections. You'd open a connection, hold on to it for dear life, do your work, and then close it. ADO.NET completely flipped that idea on its head. It was designed from the ground up for a disconnected world, where database connections are treated like a precious and very temporary resource. Now, that being said, ADO.NET still gives you a way to get data really, really fast when all you need is a simple, direct read. This is what we call the connected model, and it is built for one thing and one thing only: speed. So when a developer asks, hey, how can I get a stream of data as fast as humanly possible? This is the answer. The connected model is just incredibly straightforward. It's a clean, simple three-step process. First, you make a connection. Second, you issue a command. And third, you read the stream of data that comes back. It's simple, it's efficient, and it's as direct as you can get. Everything kicks off with the connection object. Think of it like opening a temporary pipeline straight to your database. It's your authenticated link that basically says, hey, I'm here and I'm ready to send over an instruction. Okay, so once that pipeline is open, you need to tell the database what it is you want. And that's the job of the command object. It's the container that holds your SQL query, ready to be sent down the line. And finally, when you execute that command, the database answers back with a data reader. And let me tell you, this thing is an absolute beast. It's like a fire hose of data flowing directly from the database right into your application. It's insanely fast because it's read-only and forward-only. You read one record, then the next, then the next. You can't go back, you can't edit anything. It's just pure, unadulterated speed. So the connected model is awesome for speed, but that forward-only, read-only thing, that's a major limitation. And this leads us right to the true innovation, the real heart of ADO.NET, the disconnected model. This brings up a whole new class of problems, right? What if you need to show data in a grid and let the user sort it, filter it, and make a bunch of changes before they hit save? Or what if your app needs to grab a chunk of data, go completely offline, and still be totally functional? That data reader firehose just can't do any of that. The answer is the dataset. This is the core of the disconnected model. And it's not just a list of records. It's a full-blown in-memory database. The best analogy I've ever heard is a briefcase. You take a complete snapshot of your data, tables, relationships, the whole shebang, and you carry it with you. Now you're totally disconnected and free to work with that data however you want, right there locally. So, how do you actually fill up this data briefcase? Well, that's the job of the data adapter. It acts as the bridge. It connects to the database, runs the commands to get all the data, fills up your data set, and then, and this is key, it closes the connection. Later on, when you've made all your changes, the data adapter can reconnect and figure out how to push all those changes back to the original database. At the end of the day, the crucial decision for any developer is knowing which tool to use for which job. You use a data reader for that blazing fast, forward-only, read-only access where you need to keep memory usage low. But you choose a data set when you need to actually manipulate the data, work offline, or manage complex relationships. Just remember, that incredible flexibility comes at the cost of holding all that data in memory. Okay, so we've got our data briefcase. Let's open it up and see what's inside. Because a data set is so much more than just a list of records. It's this really sophisticated object model that's basically designed to mimic a real relational database. Inside just one dataset, you can have a bunch of data table objects, each with its own columns and rows. But here's the really cool part. You also have a data relation collection. This is what defines the relationships between those tables, enforcing things like referential integrity, all right there in memory. And this is arguably the most powerful feature of the dataset. As you change the data, it automatically keeps track of every single thing you do. It doesn't just overwrite the old values. It actually maintains multiple versions of the data for each row. Take a look at this, for example. If you modify a row, the dataset knows the original value of a field, and it knows the current value you just changed it to. This version tracking is the magic that allows the data adapter to later generate the correct update statements to save your work. It knows exactly what's different. So a completely self-contained, in-memory database that tracks all of its own changes? It sounds amazing, right? And it is. But like with any powerful tool in software development, there's always a trade-off. So what's the catch? The chief disadvantage, the big one, is memory. All of that power, all of that flexibility, it comes from loading what could be a very large chunk of your database and its structure right into your application's memory. It's a complete snapshot, and snapshots can get pretty heavy. And this memory footprint becomes a really critical design decision in certain situations. I mean, if you're dealing with massive datasets, trying to load millions of rows into a dataset is just a recipe for disaster. On clients with limited memory, like maybe some mobile or web apps, it can be a total non-starter. And in high concurrency server applications, having hundreds of these large datasets floating around in memory can chew through your system resources in no time. Which leaves us with the fundamental question every single developer has to ask themselves. You've got the data reader for raw speed, and you've got the dataset for incredible flexibility. Understanding that trade-off? Well, that's everything. So for your next project, which tool is the right one for your job? And that's our breakdown of the core connected and disconnected models in ADO.NET. If this explainer helped you wrap your head around these critical concepts, let us know by hitting that like button and subscribing. We'll be back with more deep dives into the technologies that power modern development. Thanks for watching.